Okay, so 5-2. Most of this is also going to be review for us. We've talked about these parallel lines and what that means. And if we have a transversal line, then that means that intersects both of those lines. The transversal line intersects two lines in the same plane. All right, so this flat surface is our plane. Now, we weren't using, and we'll use the terminology now, all of the angles that are on the outside of the sandwich of these two parallel lines are exterior. All of the angles inside the sandwich of the two parallel lines are interior. So our angles 1, 2, 7, and 8 are all exterior. Our angles 3, 4, 5, and 6 are all interior. Now we've already said that angles 1 and 5 are corresponding angles. We've already given them that term, but now we can define it. A corresponding angle, this means that they are on the same side of the transversal line. So they're on that same side, and they're on the same side of their parallel line. So notice that 1 is on the top part of that parallel line and to the left of this transversal, and angle 5 is also on the top and to the left. So using this definition, you should be able to identify all of the rest of the corresponding angles. Now, angles 3 and 6, we're calling those alternate interior angles, and they are alternate because they're on the opposite side of the transversal line. We call them interior angles because they're inside the two parallel lines. So 3 and 6 are alternate interior angles. They are also not adjacent. They can't be adjacent. So 3 and 6 would be alternate interior angles, and the other pair would be 4 and 5. And now if you take a look at 1 and 8, so up here and then down here, those are going to also be alternate angles. They're on the opposite side of the transversal, but now they're on the exterior side, so they're alternate exterior angles. They are not adjacent, and they are outside of their two lines. So here 1 is on the top and 8 is on the bottom. Now 3 and 5, these guys are called same side interior lines, and that is because they're on the same side of the transversal. So if I come back up here, 3 and 5, they're on the same side of the transversal. They are interior because they are inside the two parallel lines. So much for definition. Your book wants you to work with a computer, and we don't have the program that they want us to work with, and so we're gonna do this instead. I've drawn two parallel lines, parallel line CD and parallel line AB, and I've drawn one transversal EF. And then if I take my protractor and I place it carefully so that it is placed correctly on my flat line here, then I notice that this angle here is about 75 degrees in measure. So if this guy is 75 degrees, that's my angle AHG, so AHG. This guy's about 75. And now we've already talked about the fact that supplementary angles make up 180, so that tells us that this angle is 105. We have talked that corresponding angles are equal, so we know this guy is 75. We've talked about the fact that the opposite angles are vertical angles are equal, so that's 75, and this has to be 105. But now take a look at the rest of the patterns. Our same side interior angles. What is the pattern between the same side interior angles? And what is the pattern between the alternate exterior angles, here and here? And what is the pattern between the same side exterior angles? So take a look at that. If you can recognize those patterns, that makes solving these angle problems so easy. So what I want you to do is I do want you to answer 1A through 1D on page 180. When you're labeling the angles, make sure you have the angle sign and then the letter, so BHF for this guy and BHG for this guy. But don't worry about when they ask you to confirm it with the computer program, because we're not using one. Now on page 181, they ask you to justify, not for this picture, for the picture that's on 181, so you want to look at your book. They want you to justify the fact that the angles 3 and 6 are equal, and they want you to do that by saying what transformations you would use. Now remember, transformations is just how things are changed or moved. So the first thing you can do is if you imagine angle 3 and you rotate it, meaning just turn it around like that, okay? So if you're going to rotate angle 3 about the intersection point of your lines A and T, so you take from one point and you're going to rotate it around and then translate it, meaning just move it, okay? So translating, moving it along that transversal line T, if you bring it all the way down, it's going to perfectly align with angle 6. And this is how you would justify that angles 3 and 6 are equal. Now what I want you to do is I want you to take a look at page 181 and 182. I want you to answer those as best you can. When you come in, we'll use those for a brief discussion before we jump into the meat of the work of page 183.